Hello, teacher. Hello, students. Welcome to today's lesson on the thermal properties of matter. In our last lesson, we defined the term phase change and examined the properties of a substance as it goes through a change of state. We also reviewed the concepts of latent heat of fusion and vaporization. We expressed the equations necessary for finding the specific latent heat of fusion and the specific latent heat of vaporization. In this lesson, we will be studying some experiments in heat capacity and relate our previous terms to experiments involving a calorimeter. Let us begin. Students, let us review some definitions. You may remember that calorimetry is the study of heat capacity and heat exchange in different physical and chemical processes. The tool we use to experiment in calorimetry is the calorimeter, which we use to measure the heat of chemical reactions or physical changes as well as heat capacity. There are many different types of calorimeter. Simple calorimeters are the ones we will use most frequently in our studies. They are made up of a few simple components: a thermometer, a metal container, and a combustion chamber. This demonstrates the use of a calorimeter. To begin, we add a quantity of water to a container to get a measure of its mass in kilograms. We have a mass of 0.7 kilograms of water. Then the water is placed in the calorimeter. The calorimeter, in this case, has a 1 liter metal container. We take an initial reading of the water's temperature. The water, in this case, is roughly room temperature at 20 degrees Celsius. The experimenter then puts a cover on the calorimeter, which is connected to an electric heater. The electric heater applies 1 kilowatt of heat to the water per second. The heater takes approximately 200 seconds to push the temperature of the water to the boiling point. Since we know that 1 kilowatt times second is measured in joules, we can conclude that 200 kilojoules are required to bring the temperature of this mass of water to boil. This experiment has established the specific latent heat of vaporization in this mass of water. To discover the specific latent heat of fusion, we can conduct a similar experiment. Students, let us do an activity. Based on what we learned about finding the specific latent heat of vaporization of water, what would the steps be in an experiment to discover the specific latent heat of fusion? Take a few minutes to write down your answer.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I am sure you noticed that the process is very similar to the experiment we just discussed. Let us go through the steps together. To start, we add ice to a container and measure it in kilograms. Then, we transfer that ice to the container of the calorimeter. Next, we take an initial reading of the current temperature. Then, we apply conditions that will increase the temperature of the calorimeter. The simplest way that would accurately mirror our first experiment would be to place the calorimeter on a heater. We must establish how much of a reduction in heat energy happens per second with the new conditions we have applied in order to make our conclusion. At this point, we monitor the temperature of ice in the calorimeter over a period of time to determine how long it takes for the increase of heat energy to cause the ice to melt. Once the ice is fully melted, we can remove it from the heater to determine the latent heat of fusion. If you answered this question with the same steps as presented here, you are able to determine the specific latent heat of fusion in any experiment. Excellent work. Students, here is another question. Is it possible for a substance to change state without a change in temperature? Why or why not? Please write down your answers.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Did you think about the phase change diagram we saw in our last lesson? If you did, you would remember that this diagram shows a measurement in temperature and pressure. Therefore, the answer is yes. Pressure, in some circumstances, can cause a change of state without a change in temperature. In this demonstration, an experiment is being conducted to prove this point. A mason jar is filled with a quantity of water. Connected to the lid is a length of tube which leads to a faucet. A junction in the tube allows water to flow directly into the sink. Because the stream of water follows a laminar flow, the air coming through the tube gets pulled into the water stream. As air flows into the vacuum, the pressure in the jar changes as indicated on the pressure valve. When the pressure changes significantly, the water begins to boil. Notice that the experimenter has no problem putting his hand on the jar. Its temperature is not high. Students, today we have learned about the different applications of a calorimeter as they apply to experiments in latent heat of fusion and vaporization. We have studied some experiments with examples of phase change and reviewed what steps are required to conduct a successful experiment of your own. Until next time, thank you, teacher. Thank you, students.